can you hear me? Okay, I apologize for not having a title slide. I didn't want to waste one of my 2 slides on the title page. My learning segment that I've been developing is based on chemical reactions. The core curriculum I chose started with physical versus chemical changes, going on to the different types of chemical reactions, balancing reactions, chemical equations, and then reaction rates and equilibrium. So I've been trying to really develop my lessons on having students use their observations first and then apply them to kind of piece together the curriculum and understand, have that understanding of what's going on before, so they're not just memorizing concepts. And so for chemical versus physical changes, which would be kind of the intro into the chemical reaction segment, they would start by first observing different types of changes that they're familiar with, like lighting something on fire, an ice cube melting, and then after that learning the concepts and thinking about, okay, now which of these actually are the molecules changing chemically and which is just a physical change. And then the next lesson, the types of chemical reactions, which I'll be demoing tomorrow for the Capital Region folks, has students observe and perform 4 different chemical reactions in the lab, each of which is one of the different 4 types. And based on their observations and knowing the starting materials, they should be able to kind of figure, okay, this is forming a gas, these are the possible gases that could be forming, and figure out what's going on in the chemical reaction. And then afterwards in the lecture, be asked, okay, what did you observe, what's forming, and be able to figure out the different ways that chemicals can combine or separate and form in chemical reaction. And now if you want to move to the next slide. And so the past learning segment, or the past module, sorry, I was working with reaction rate and Alka seltzer tablets and water. I got this idea from our Second Life meeting with Laura Cascioli. I just want to give credit where it's due. And having students, create their own experiments, I had the idea of first giving them a procedure, and they know exactly how much water they're using, and they time the chemical reaction and average the class data to learn about reaction rate, and then ask them to go back in the lab and change whatever they want in the experiment to try to figure out how they can, what variables will affect reaction rate. And so they might think, okay, we're going to do a different temperature, we're going to do more water, we're going to crush the tablet, and then after the class collects all of their data, since there will probably be different, some similarities, multiple groups will probably change the concentration, they take that data and they graph it, create plots and mathematically analyze it to figure out how these different variables are affecting the reaction rate, and that would kind of lead into a lecture on, actually how we change reaction rate, the official equations, but now they understand because they've basically created those equations themselves. And finally, for the temperature probe assignment, I thought if I apply the same Alka-Seltzer and water reaction and use a temperature probe, you can actually see the reaction progress as it's an endothermic reaction. All reactions are, well, not all, but most reactions are either exothermic or endothermic. Isomerization would be neither of them. But anyway, they would take some of their experiments that they created from the previous lesson and then use a temperature probe and monitor the temperature change and see, again, okay, not only can we use a stopwatch and just see when the Alka-Seltzer tablet stops fizzing, but we can see the temperature change and monitor and see, okay, the temperature change, it takes a small amount of time, but the temperature's changing more dramatically, the rate's increasing, and they can actually visualize what's going on in the reaction. So that's all I have. Are there any questions?
Yeah,
Alright, well,
I agree. I think everyone's seeing the value in this. And I like how you have them looking for subtle things too, that temperature change in with the Alka seltzer, and how you went from the lab where they're actually gathering the data and the experiences back to the classes later where you can talk about it. That's very powerful. We tend to always think we have to tell them and then they have to see it. But going the other direction can be powerful too. So that's excellent. So
great,
Tara, why don't you start moving up? Yep, backwards design. And nice job.
Hi guys, can everyone hear me? Okay, so my unit that I did is on Hudson River discharge, and I planned it out to be actually kind of like a post-assessment where I wanted students to think creatively after they had studied weather and climate. And one of the things that I noticed with students is their understanding as far as weather and or climate is it's compartmentalized in so much as they really don't think about, you know, how it really affects how they interact and what the real difference is. It's kind of like, all right, we're going to spend a week on weather and we're going to spend 3 days on climate, and that's pretty much the end of it. And they don't really think about it, how it affects their lives or anything like that. So I thought, why not use the Hudson River? Because for most of us, it's kind of close, or it's, you know, something that people know about and can understand, and, you know, it's been studied for a long time. So, let me see. Oh, and one of the things I thought that was really cool is they're going to create a spreadsheet, and they're going to have their data, and they're going to get it off of two distinct websites. One is USGS, which is United States Geological Survey, which is a government website, and then alternatively the second site they're going to get their data from is weather.com, which is a commercial site. And one of the takeaway lessons that may or may not explicitly be told to them is I want them to compare the two different types of websites and how much easier it is to find data on USGS, but there's so much data. I believe one of my students actually called it junk data because they got a little frustrated because they couldn't, you know, easily find what they were looking for. They had to search around and determine what was actually useful to what they were doing and what they actually needed. So there was just so much data that they had to change their parameters for what they wanted to find for the lab. So we kind of put the lab in their hands and said, okay, this is what this is what we want as an end result. How do you think you can best get there? And next slide, please. Okay, so like I said before, the students hopefully will be engaged because the bulk of the data that they gather, they choose their own locations. So they can use a town close to the river, possibly where they live, depending upon which gauges are useful. And one of the newer features on USGS is Google Earth has a skin where they can actually, quote-unquote, fly to explore the gauges in their own neighborhood, which is not limited to the Hudson River, so hopefully that'll get them a little more interested in what's going on in their own towns, not necessarily just for the purpose of the lab. There's quite a few challenges in the unit, I'm going to be honest. This started out as a really simple idea, and the more I delved into it, the more complicated it became, but I think that's a good thing, because there's variables that the students can look at and change based on what they want. For instance, a lot of gauges are no longer currently active, so they might have a gauge by their house that was discontinued 3 years ago. So it's really interesting data, but it's not very useful for an annual graph. Let me see. Oh, one of the things I thought was really interesting that students really have a problem understanding is as far as discharge. And as you can see on the climograph on the bottom, which is actually data that I gathered, kids seem to have a real problem understanding the lag time as far as the source of the Hudson River and the Adirondacks and snow melt, and they're like, no, we get more rain, so the river's obviously going to be at its highest point in the summer. And it really gets them thinking about what sources and what uses the Hudson River actually serves, as far as in New York all the way, you know, from north in the Adirondacks all the way down. Same thing along the Mohawk Valley, you can work that in. And it's just, it's really something I found was very interesting. Oh, I'm sorry, dear, it's actually 10th grade. 10th or 11th grade, depending upon how in-depth you want to go. I think that's about it. I think I hit everything. Any questions?
Well, it's Eileen. I'd just like to make a comment. This is excellent. And today, as you saw in our all-pervasive Ed TPA, which is setting exit requirements, but more importantly than that, it's setting the tone for the way we need to teach science. We're looking at gathering data, experimental data, and real-world data is considered just as true as data you would gather in the classroom. It's always messier when you do something real, when you step outside of a very prescribed exercise. But as I think Tara just pointed out very brilliantly, you're getting them to think science. You're getting them to see that measurements were taken all around them. Citizen science is becoming a very important concept. You want them to leave your classroom concerned about science and the world around them and how scientists use that data to create the very complex and wonderful systems that we live in. So I'm actually dealing with a country in South Africa, South Sudan right now, realizing how much we have in this country that we take for granted. So getting students to delve into those deep data points and all that is more uncomfortable than just giving them a worksheet. But I think you're to be applauded that this is really where you're creating those higher levels of thinking and maybe someday getting more scientists out there.
Perception that because the Earth comes closer to the Sun for a little bit during its orbit, then that's summer. But that's not true, because